Madhu, your turn now.
Imagine science fiction turning into reality. A world where electronics are not only unbreakable, but they're far less clunky as they are right now. So if you think about conventional electronics, they are hard, they are rigid, they are brittle. All of you might have the experience of dropping a mobile phone and having the screen shatter, and that's pretty much the end of it sometimes. Each of these electronic devices also have what are called coatings in them, which are very thin layers, as thin as a sheet of paper or many, many times thinner than a sheet of paper. And these are typically made again of oxide materials, which are similar to glass. So once again, brittle things. On the other hand, you have what are called flexible polymers. Now this is a fast growing field, and these are basically materials which are very similar to materials used in contact lenses. They are soft, they are pliable, and they are mechanically flexible. So the challenge which I had to face was, how do you bring these two very diverse materials together? So that's the innovation which I had to bring through. So what I developed, and what as a team we developed, was a transfer technique which enables transparent stretchable oxide electronics. So what we developed pretty much looks like that. So that's basically an electronic device which, as you can see, is extremely thin, it's stretchable at the same time, and therefore means unbreakable, and also it's transparent at the same time. As a result of this transfer process, the oxide layer which we transfer over takes the shape of those plates which you see in the middle. So we named this a microtectonic effect, but because it kind of resembles tectonic plates which make up our Earth's crust. And by taking that shape, that gives it incredible stretchability, and it also gives it much better sensitivity for various applications. So using this transfer technique, it just opens up many, many applications. So to date, we have developed applications and demonstrated them in the form of gas sensors as well as in the form of UV sensors. So we all live in an age of pollution. So imagine there's so much pollution around. In fact, I've heard in places in Singapore and China, people actually check how much pollution is there before they step out onto the streets. So imagine you have a little patch which you can wear on your skin, which is actually going to track the amount of pollution which is there. Or you're inside a mine and you want to track whether there's any dangerous gases present in there. On the other hand, imagine you're on the beach and you're having a lovely day, you're just sitting out there, you've applied sunscreen or you're not applied sunscreen, and you have a little patch on you which can actually tell you you've had this much UV exposure. And then it reminds you to actually go in and put on some sunscreen and come back again. So if you Google wearable sensors, that's pretty much the kind of image which you get right now. Not quite the kind of future which I'm imagining, but what it does show you is that the possibilities are endless. You could have these patches on your skin or in your contact lenses in your eyes. So I'm Madhu Bhaskaran from RMIT University, and what I imagine or envision for this world is that these low-cost biocompatible patches will become an integral part of our health and lifestyle. Thank you.